Hey guys, welcome back to On the Spot STEM, and today we're going to be looking at 2019 USACO Bronze number 1. And the problem reads, to pass the time, Bessie the Count and her friend Elsie like to play a version of a game they saw at the county fair. To start, Bessie puts 3 inverted shells on a table and places a small round pebble under one of them. At least she hopes it is a pebble. She found it on the ground in one of the pastures. Bessie then proceeds to swap pairs of shells while Elsie tries to guess the location of the pebble. And you can read the rest of the problem. It's quite straightforward. And so basically what happens is that there are 3 shells basically flipped upside down, and then Bessie is going to Bessie is going to be trying to guess. It's just Bessie's going to try to is it Bessie? Oh wait, sorry. Elsie is going to try to guess, which shell is under what, and the question is going to ask pretty much if find the number of maximum number of times Elsie could have been correct. So basically, the 3 columns are A, B, and G. A and B are pretty much what Bessie's swapping, and then G is pretty much Elsie's predictions of where each thing is, or like pretty much where the pebble is. So basically, the first line of the code is pretty simple. It's just saying how many following lines are going to be, and then the next line is the columns. So then let me just go over this example and show you how we're going to work through it. 1, 2, 1, 3, 2, 1, and then 1, 3, 1. So basically, this is going to be A, B, and G. And then what I see here is that if we have the pebble location at 1, then the only time Elsie gets 1 right is exactly on her first guess. Is exactly on her final guess, because that's when it's going to be in the first position, and that's when Elsie guesses that G is 1. And then if I say it starts off with position 2, that means she gets it right the first time after the swap. And then the second time, since the 2 and 3 are swapped, it's still in the first position, so she gets it right again. But then the third time it's swapped and she gets it wrong. And then if it's in the third position, it never works out. So basically what we can see here is that we can basically kind of brute force our method through, because there's only 3 possible integers, 1, 2, or 3, and we can basically run the 3 simulations of each time the pebble is either starts off in the first location, starts off in the second, or starts off in the third, and then we can take the maximum of those 3 values. So that's pretty much it to it, not too much. And then all we have to do is, when we keep track of the code, let's say we have these switches here. If the pebble is in, say, A here, then I have to make sure that I have if statement saying if the pebble is in A, then I need to move the pebble to B, because that's when it's going to be, and vice versa. Where if I find the pebble in B, then I'm going to have to move it to A. Like, obviously these circles and arrows aren't representative, but I'm trying to give a picture idea of what it's supposed to look like when we code it up. And here's how we would code it up. I'm using XCode on my Mac, so the XCode language is going to be C++. So include IOStream, include algorithm, include fstream to do the reading, using namespace, int main. So outside of this main, I'm going to just define quick variables so that they have global access. So I'm going to say int n a100, since it gives us here that it's going to be 1 is less than n is less than equal to 100. So the maximum size of A and B and G are each going to be 100. G100. So we have that. So in their main, our first step is going to be to read n. And then after that, we're going to want to read each of A, B, and G. So I'm just going to run a quick for loop. AI, and then read in BI. I'm going to read in GI. I keep having a tendency to type C. And then after that, I'm going to fix the simulation for, equals 1. And the reason I'm doing 1 to 3 is pretty much this for loop over here. I can put a comment. This is going to cycle, this is going to be our brute force. This loop right here is the one that's going to go through each of these 1, 2, and 3 cases right here. And then basically starts off with, let's say the rock starts off in the first position, and then the pebble starts off in the second position, third position. So I'm going to loop these 3 cases here. And so outside of this, I should probably have an integer saying like integer the high, which is going to be the high integer, or like the maximum. I would say maximum, but in include algorithm, we're going to use it for the max function, so it might be a little trippy. So I'm going to use int high equals 0. And then at that point, after you get the int high equals 0, I can say that high equals we'll say maximum of high and then the optimal of I. So basically what I'm saying here is that I can start off with high equals 0, and then this is going to be the maximum value of high and optimal equals I. Now I'm going to make a method for optimal, which basically takes this number 1 and sees how many times they win. And if that number of wins is higher than like with my current high number, then it's going to replace that right over here. So I'll make this method outside right here. So I'll say optimal integer optimal I, because I wanted to return the number of times I win. Integer optimal int I. And then at the end, I'm going to have an int count equals 0, and I know that off the bat I want to return a count at the end. So I'm going to start indexing pretty much. So let's say our current index, or I'll say location, like the location of the pebble. So I'll say location of the pebble equals I, because like I'm going to say hypothetically that we'll start off with 1, and the first location is going to be at the 1 spot. So from the 1 spot, I'm going to say for int I equals 0, I is less than n, I plus plus, which is where I pretty much is cycling through each of the columns of A, B, and G. Then I'm going to say that if the location is, or if AI is equal to the location right now, then I'm going to want it to swap it. So I'm going to want it to move to the B row. So I'm going to say location now equals BI. And after the same thing, I'm going to say else because it's else if statement, because if I do just if, you can play around with this and you'll see why the output of what I need, instead of being 2, it's going to be 3 in the test case. So I'll say else if BI equals a location. Then I'm going to say the location now equals AI. I cut the quick typo right there. Cool. And at the very end, you want the counter to see, like, if you've been counting everything properly and all that stuff. So then I'm going to see that if, let's say, if the location is indeed at GI, then at this point I'm going to want to increase the count by 1, because that means the prediction here is going to be correct if it's in the G column. Like if I guess 1 here, and then it actually turns out to be in the position 1, then you want to get the points for it. So this is pretty much the optimal method really quickly. And over here, once we have the high, that's pretty much our answer, because we just want the most number of wins possible. So I'm going to end up outputting high. And then you can pretty much just test this on your own, honestly. But first, time simplicity, I'm just going to run it straight into the thing. So I'm going to say for if stream in, and then the name is shell, so shell.in, and then of stream out. People like to use fin and fout, but I just use out, or f out, however you want to pronounce it. So I have to remember change that to in, change that to in, change that to out, build my code, have it saved, and it builds successfully. So I'm going to go to USACO, C++, choose my file, not bronze 1, I want bronze 2, bronze 1, and then main C++, I'm going to submit that. And boom, we get all 10 test cases, and from what you see, they actually run in 1 millisecond. They run very fast. The ends take it a bit. But this is pretty much how you solve this problem on this contest.